Hello everybody. We are going to move on to chapter 6, sections 2 and 3. We're going to be talking about matrices and systems of equations. And so one way that we can solve systems of equations that are a little bit easier and our calculator can help us solve this is by making it a matrix. And no, we are not talking about the matrix. We are talking about matrices, which are a mathematical thing that we can use. So a matrix is something filled with numbers. So we have like 3, -1, 5, 7, 2, 3, -4, 8, 5, 1, 1, 3. So it's a set of numbers, and they usually represent something, but we can also just work with matrices on their own. And they are defined by their columns and the rows. So we would say that this is a 4 by 3, a 4 by 3 matrix. And so these are always, the columns are always written first by the rows. And so the way that we are going to be using matrices for this class is using an augmented matrix. And so if we have a system of equations, so 2x minus 3y equals 7, and x plus 4y equals -2, we can make this into a matrix that is a 2 by 3. So that means that we're going to have 2 rows since we have 2 equations. And then we're going to have 3 columns, where our first column is the coefficients from our x's. The second column is our coefficient from our y's. And then we're going to have a little line where our equal sign is, and then the number that it's equal to. So for this first equation, this would be 2, -3, 7, 1, 4, -2. And so then the way that we use these matrices to help us solve systems of equations is we do row operations. And so these row equivalent operations are what we can do that do not change the values of the matrix. And so it's similar to what we do whenever we do substitution and solving for a system of equations, but it's a little bit more systematic. And so we can exchange any 2 rows, multiply each entry in a row or a column by a non-zero constant, and then add a non-zero multiple of one row to another. So these are the technical terms of what we can do to help get us into row echelon form or reduced row echelon form. But we're mostly going to be using our calculator for this, so we're not going to go through those formal steps. Now, the main goal in working with matrices is to get it to reduced row echelon form. And so row echelon form means that we have a matrix with 1s along our diagonal and 0s below it, but then we could have numbers up here, so we could have like 0, 3, 4, 6, 1, 0, 5, 3, 4, -2, 7, 4, -3, 5. So with row echelon form, we want 1s on diagonal and 0s below. But then reduced row echelon form is even more reduced than this. We want ones along our diagonal, zeros below. Let me write that a little bit better. So we have ones along our diagonal, zeros below, but then we also have zeros above each of our ones. And then with an augmented matrix, that means that we'll have zeros on our diagonal, ones on our diagonal, zeros everywhere besides the ending numbers. So ones on diagonal, zeros above and below. So if we look at this example, for which ones are row echelon form? So first off, B is not row echelon form or reduced row echelon form because we don't have ones along our diagonal. For C, we have zeros below our diagonal, but because of this 3, this does not make it row echelon form. And then with F, because our 1 is here and not on our diagonal, this is also not row echelon form. So A is row echelon, so is D and E. But now a step further would be to if it is reduced row echelon form. And so if we look, we have ones on our diagonal and zeros everywhere else. So this is reduced row echelon form. And with this one, even though this diagonal does have a 0 here, along our diagonal is only zeros, or is only ones, and then we have 0 above and below. So this is reduced row echelon form. So if you have questions on this, please bring this to class to understand it a little bit more. So then, if we have our regular two-variable, two-equation system of equations, we can easily solve that with our graphing, elimination, or substitution. But whenever it comes to 3 or more variables with 3 or more equations, it gets a little bit more complicated with our substituting and putting everything back together. And so this is where matrices really help us. And so, again, with this, we're going to have our rows be based on our equations. So we're going to have 3 rows in our matrix. And then because we have 3 variables and our equals, we're going to have 4 columns. So we'll have a column for x, a column for y, a column for z, and then a column for our numbers. And so if we look at this, we do not have a 0, or we do not have a y term in our last equation, but we can think about this as plus 0y. And so as we go to fill this in, our first row, we're going to put our x term in our first column. Then our first row, second column will be our y term. So the coefficient in front of y is -1. Our coefficient in front of z, which would be our third term in our first row, would be 4, and then -3. And so then for our second equation, which makes our second row, that would give us 1, -2, -10, and -6. And then our last row, our third row, we would have 3 for our x, and then because we do not have a y term, our second column, third row would be 0, then 4, and 7. And so we want to get this into reduced row echelon form because then that tells us what x, y, and z equal. But instead of having to do all of the row operations by hand, we can let our calculator do that for us. And so down here are the steps written out on your calculator, but let's go ahead and look at what that looks like. So if you go to your graphing calculator, we want to edit a matrix, so we're going to hit second and then the inverse button, but you'll see matrix written in blue above there. So we do second matrix. We can see that we have a matrix written in here, but it's a 1 by 1. So we want to go over to edit. We'll edit for A. And so we've established that we want a 3 by 4 matrix. So we would do 3 by 4. You hit enter, and then our matrix pops up. So then we just enter our values from the matrix that we have. So it'll be 2, -1, 4, -3. So if you hit enter, it just goes to the left and then goes down. And then 1, -2, -10, -6, 3, 0, 4, and 7. So this is also really important that we include our negatives in this, because otherwise we would get different answers. So then to get this to be reduced row echelon form, we want to go back to our home screen. So we do second quit. And then we want to go back to second matrix and go over to math. And then you have to scroll down, but it's option B where it says RREF, and that stands for reduced row echelon form. So if you just hit A, that's the row echelon form, but it doesn't quite get us what we want in order to solve. So we want to select B for RREF. Now we have to go and select our matrix. So then you'll go to second matrix, and then we just select matrix A because that's what we typed in. And then you hit enter. So this is our reduced row echelon form. So go ahead and write that on your paper. So this reduces to 1, 0, 0, 3, 0, 1, 0, 7, 0, 0, 1, -1/2. So again, we want to remember that our columns represent x, y, z, and the number. And so what this means is that now we know that x equals 3, y equals 7, and z equals -1/2. And so in my math lab, it will want you to write this as a point. So this would be 3, 7, -1/2. So please come with questions into class, and we will go over the rest of these systems and the application problems in class. Have a great day.